Okay, today let's look at the ideal gas law, and I'll work a couple of examples for you here. Okay, let's first see what we've got. What volume in milliliters will 0.00660 moles of hydrogen gas occupy at a pressure of 0.907 atmospheres and a temperature of 9 degrees Celsius? Okay, I recommend that you first write down the equation, PV equals nRT. That way we can see all the variables, have everything set up. Now let's go back through the problem, and each quantity, let's put it into position. So we have 0.00660 moles. Okay. R is is the gas constant. Okay. Has a value of 0.0821. And the units on it is liters, atmospheres, per mole, Kelvin. Okay. Relates PV, N, and T. Okay. Now our temperature. Our temperature was given at 9 degrees Celsius, but with gas laws you must use Kelvin temperature. You have no option. You have to use Kelvin. So Kelvin, remember, you take the degrees Celsius and you add 273.15 to it, and that equals your Kelvin. So 9 plus 273 is 282. We won't use the 0.15 because of sig figs and decimal or digits of precision. And then we're hunting for our volume. Our pressure was given as 0.907 atmospheres. Okay. I really think this helps if you write it all down, put everything into position so that you can see the knowns versus the unknown. And then we'll isolate. So we divide both sides by 0.907. And then we'll solve. So we'll have 0.00660 times 0.0821 times 282, and then we'll divide by 0.907. Okay? That'll give us our volume. Now I'm going to take 3 sig figs because this Kelvin temperature has changed over to Celsius, but that's really just 1 sig fig. So I'm going to have 0.168. And what would be those units? Well, I would go back to the R and notice that the volume in the R was liters, so I have 0.168 liters. Now, they've requested that we change it to milliliters. We know that 1 liter is 1,000 milliliters. So our volume would equal 168 milliliters. Okay? Alright. If you need more help, then I'm coming up with a second example problem of PV equals nRT, the ideal gas law.